Good morning, dear student. Today we discuss about the acetate melvenoate pathway. Through this, it is also called it as an isoprenoid pathway, or it is also called as HMG-CoA reductase pathway, in which the major compounds are synthesized, that is the terpenoids. These isoprenoid pathway or acetate melvenoate pathway are majorly for the compounds of the isoprenoid compounds, which is a mostly diverse family of the natural product. The carbon skeleton is derived from the branch C5 skeleton of the isoprene, that is C5H8. It is a basic unit which is formed, and when the addition of the number of isoprene unit, then the terpenoids, different classes of the terpenoids are synthesized. It is acyclic, mainly isoprene mimesis is readily recognized in the acyl salicylic acyclic members. Okay, these are C5H8. It is a carbon and hydrogen chain, mostly in that, and these are not in a heterocyclic ring. It is also called as a isoprenoid pathway or HMG-CoA reductase pathway, and it is very important for the mostly in plants and in a bacteria also. The major two important metabolites are synthesized during this pathway. That is one, that is isoprene unit. We called it as the isopentyl pyrophosphate, that is IPP, isopentyl pyrophosphate, and another one, that is a dimethylallyl pyrophosphate, which are used for synthesis of the different biomolecules. Near about 30,000 biomolecules in various plants are synthesized by using this IPP or a dimethylallyl phosphate. This pathway is first we can see the what are the steps in this pathway. The acetic acid is combined with the coenzyme A and form acetyl-CoA. That is acetyl coenzyme A. What is the starting material? That is the acetyl coenzyme A. When two molecules is undergoes into the combines, that is the two molecules of acetyl-CoA are combined, then it goes undergoes into the condensation and with the acetoacetyl-CoA thiolase, it forms the acetoacetyl coenzyme A. Acetoacetyl coenzyme A is again condensed with the another acetyl CoA to form 3-hydroxy 3-methyl glutaryl CoA. 3-hydroxy 3-methyl glutaryl CoA. Two molecules of acetyl CoA are combined, then form acetoacetyl CoA. Again acetoacetyl CoA is with the help of the enzyme HMG CoA synthetase attached with the one more acetoacetyl condense with another acetyl CoA to form 3-hydroxy 3-methyl 3-hydroxy 3-methyl glutaryl CoA. It is called HMG CoA. This HMG CoA, now these two steps are the condensation step. Now here the reduction is occur. The HMG CoA is reduced to malvenoate. HMG CoA is reduced to malvenoate. This malvenoate is phosphorylated with the phosphate 3 kinase by the enzyme and converted the 5H position to yield the malvenoate 5-phosphate is called phosphomalvenoic acid. Malvenoate 5-phosphate and then malvenoate 3-phosphate. The malvenoate 3-phosphate is formed. Yield malvenoate 3-phosphate. There are the two at a malvinoid 3 kinase form the malvinoid 3 phosphate, and the phosphate group is attached to the 5 position, then it is a malvinoid 5 phosphate. This malvinoid 5 phosphate is phosphorylated to yield malvinoid 5 phosphate is converted to a decarboxylated and to yield malvinoid pyrophosphate. This malvinoid pyrophosphate undergoes into the decarboxylase and formation of isopentyl pyrophosphate. Malvinoid 5 phosphate to malvinoid pyrophosphate, malvinoid pyrophosphate to isopentyl pyrophosphate. This isopentyl pyrophosphate is converted to dimethylallyl pyrophosphate. Isopentyl pyrophosphate is converted to dimethylallyl pyrophosphate. Another way where we can see at a 3 position the phosphate group is attached, that is the malvinoid 3 phosphate. Then it gives a malvinoid 3,5 biphosphate. Then again isopentyl pyrophosphate, isopentyl phosphate and isopentyl pyrophosphate and dimethylallyl phosphate. This phosphate group is attached at the 2 position, may be attached to the 3 position or 5 position. Then malvinoid 5 phosphate to malvinoid pyrophosphate and malvinoid pyrophosphate to isopentyl pyrophosphate. Another way, malvinoid 3 phosphate to malvinoid 3,5 diphosphate, isopentyl pyrophosphate and isopentyl phosphate and then isopentyl pyrophosphate. So in a both way the IPP, which is important for the terpenoid, for the production of the terpenoid, it is called the isopentyl pyrophosphate, that is IPP unit. And another is when it's these are the isomers of each other, that is a dimethylallyl pyrophosphate. Terpenoids is a class of natural product which is a diverse structure and mainly essential for the a number of biological functions. This according to the C5 unit, that is a isopentyl pyrophosphate, involve the synthesis of the terpenoid. These are classified on the basis of how many number of isoprene units are present. That is, if only the one isoprene unit, then it is called hemiterpenoid. If two isoprene units are there, then it is called monoterpenoid. If four isoprene unit, then it is called diterpenoid. Then 6 isoprene unit, then it is called triterpenoid. And when 8 isoprene unit, it is called the tetraterpenoid. Means depend upon the number of IPP, it is classified the class of the terpenoid. How these classes are formed and how it is occur. The first, that is a head and tail condensation, is occur between the dimethylallyl pyrophosphate and isopentyl pyrophosphate, which are the isomers of each other, and it is called the hemiterpene. Means only the one unit of C5H8 is present. When one more pyrophosphate group is attached, when two isopentyl pyrophosphate is added, then two molecules are attached and it is called the geranyl pyrophosphate. Geranyl pyrophosphate or geranyl diphosphate. Here the two molecules of the isoprene, then it is called the monoterpenoids. Then one more IPP means isopentyl pyrophosphate is attached and it becomes the sesquiterpenoid, in which C15, the carbon atom reaches to the C15, it is called a sesquiterpenoid. When one more IPP attached, the total number of the IPP get 4, then it is called a diterpenoids. That is how the carbon atom reaches to the 20. Again, when the two molecules of isopentyl pyrophosphate is attached, then it is converted to squalene, and squalene gives the triterpenoids. then phytin, and it gives the tetraterpenoids. Means the number of isoprene units are attached and the class of the terpenoid is a form. If we see the examples of monoterpenoids, mainly our linalool, geraniol, citral, which is present in a which is and these are the in a acyclic form. In this way, the monoterpenoid, diterpenoid, triterpenoid, tetraterpenoid are synthesized, in which the number of isoprene units are attached, and mostly these are the acyclic compounds, and therefore these easily get the breakdown, and it shows the specific type of the aroma. These are not very much stable. There are the different examples of terpenoid we will see. Monoterpenoids, you know, the citral, linalool, which is present in a citrus fruit. Diterpenoids, diterpenes such as retinol, retinol, phytol, these having the antimicrobial and anti-inflammatory activity. These are present. These are mainly present in a Taxol, forskolin. Triterpenoid is in which the formula becomes C30H48. They are also having the six number of the isoprene unit and produce triterpenes, that is a squalene. It is a precursor for that. That is a glycerinic acid, lupiol, cucurbitacin, abitic acid, boswellic acid. These are the examples of these triterpenoids. Then tetraterpenoid, in which the 8 number of the isoprene units are attached, that is a C40H64. Number of the carotenoids are in a class of the tetraterpenoid. These are the mainly these carotenoids are the antioxidant activity. It can be reduce protection against the free radical. The synthesis of the plant hormones, the synthesis of the different plant hormones is also done by these carotenoids. Also, it is an important part in a food also. It's a so these are the examples, and this in this way the acetate in this way the two molecules of the acetyl CoA are combined, and the different terpenoids are synthesized. This is the acetate pathway or acetate malvenoate pathway. Another pathway is the acetate malanoid pathway, which is used for the synthesis of the fatty acid. Okay, here it is also the some means squalene like compounds are a form which is used for the synthesis of the cholesterol, but the major part is the IPP and DMAP. These are used for the synthesis of the different classes of the terpenoids. So you learn this pathway and complete the pathway, because only the one topic is remaining in our first section, that is how to pathway are determined, how the secondary metabolites are synthesized in the plant is determined in a laboratory. What are the in vitro methods we are testing, we are study that, and then our first topic is over.